Good morning, this is your stat sensei, Mr. Spensey, and this is a test review for two sample proportions. And this will be a hypothesis test on no kissing. So for many years, the medically accepted practice of giving aid to a person experiencing a heart attack was to have the person who placed the emergency call administered chest compressions plus mouth-to-mouth resuscitation, or MMR, to the heart attack patient until the emergency response team arrived. However, some researchers believe that chest compressions alone would be a more effective approach. In the 1990s, a study was conducted in Seattle in which 518 cases were randomly assigned. This is important because that's going to get rid of condition 3, no N is less than 10%. 278 to CC alone, or CC plus standard MMR, and 240 to CC alone. So let's go ahead and mark that down because we have two groups. We have CC plus MMR, and then we have CC alone. In the CC plus MMR sample, we had 278 right here, and 240 to the CC alone. A total of 64 patients survived the heart attack, 29 in the group receiving CC plus MMR, so this is 29 survived, whereas 37 survived in the CC alone group. All right. At the alpha equal 0.03, does CC alone produce a higher survival rate than CC plus MMR? All right, so they want to see if CC-MR is less than CC alone. CC alone is greater than CC plus MMR. That's what they're checking. So let's finish calculating out our P1, P hat 1, and P hat 2 since we have that information. So this is 29 over 278, and this is going to be 37 over 240. 29 divided by 278 is 0.1043. And 37 divided by 240 is 0.1541. So clearly CC alone is higher, but is it statistically higher? Did that happen by random chance alone? And that's what we're going to check on when we run our hypothesis test. So the null hypothesis is that between the two proportions, there's no difference. The alternative hypothesis, now look at the way we set this up. CC and MMR is P1 is less than P2. So chest compressions alone has a higher survivability rate. So we need to define our parameters and let P1 equal the true population proportion survival rate of survivors for CC plus MMR. In other words, true population proportion of survivors for CC plus MMR. And that's for heart attack victims. And probably should include that, but I'm not going to because it makes it longer. Let P2 equal the true population proportion of survivors for CC alone. All right, let's go ahead and start doing some work here. So our P hat C, which we have to have in order to do our conditions, is X1 plus X2 over N1 plus N2, which in this case is going to be 29. Oh, excuse me. So that's the one, the next row down, P hat C equals 29 plus 37 over 278 plus 340. 29 plus 37 is 66. I know our thing said 64, so there must be a typo that needs to be fixed at a later date. And then 278 divided plus 240 is 518. So we end up with 66 divided by 518. Oops. And it's about 12.5%, so 0.1274. All right. Let's take a look at our conditions. The first condition is either going to be random selection or a random sample or random assignment. Here it's random assignment, 278 to one and 240 to the other. So I'm going to label this one CC plus MMR. That's mainly for me. And this I'm going to call CC alone. 1, random assignment. Of 278. And that was given. Here I'm going to say random assignment of 240. And that was given. 2 independent samples. And that was given. Three, the third one, N is less than 10%, not necessary to do, so we won't because of random assignment, so we don't need to do that. But we need to do the normality conditions. And if it's a hypothesis test, you're using NPC. So N1 P hat C versus N1 times 1 minus P hat C. Now, if it's a confidence interval, it's N1 times P hat 1, but that's not what we're working with. So this is N2 times P hat C, and this is N2 times 1 minus P hat C. Well, N1 was 278. This is 278 times 0.1043, and then 278 times 1 minus 0.1043. Oh, excuse me, wrong, 1274, my bad. 278 times 0.1274 and 278 times 1 minus 0.1274. $278 times 0.1274 is 35.4. It's 35, which is greater than or equal to 10. And then 278 parentheses 1 minus 0.1274 is 243. So that one's large enough. On the other side, we have a slightly smaller sample at 240. That should be 240, not 340. So this equals 240 times 0.1274. And this is at 240 times 1 minus 0.1274. Is 31. And that's greater than or equal to 10. So 240 times 1 minus P hat C. And that's 209. And that's also greater than or equal to 10. So our sample size is large enough to use a normal approximation. Well, the formula is Z equals P hat 1 minus P hat 2 over P hat C 1 minus P hat C in 1 plus P hat C 1 minus P hat C over N2. So when we plug in, we're going to be looking at our P hat C's and our P hat 1s. Oh, and we also need to look at our sign. So this is the less than. So we want the probability that Z is less than 0.1043 minus 0.1541 over P hat C, 1274. One minus 0.1274. That's going to be over N1. We'll come back to that. We're going to have the same thing over here, 0.1274, and then times 1 minus 0.1274. And that's going to be over N2. N1 was 278, N2 was 240. So this is going to be 278. And this is going to be 240. So we're going to look for the probability that Z is less than some value. Let's find out what it is. So test number 6, which is 2 proportion Z test. All right. We had 29 out of 278 survive with chest compressions and mouth to mouth. And with chest compressions alone, we had 37 out of 240. We had less than. And we get a p-value of negative 1.6967. I mean, not a p-value, a z-score of that. And we end up with a p-value of 0.0448. Which is pretty small. And if we were looking at a 5%, we would be rejecting. But here they said, nope, your alpha is 3%. So 0.0300, 448 is definitely larger than 300. So we're going to fail to reject. So our P value is 0.0448. We fail to reject the null. There. Why did we why did we fail? Well, there is not sufficient evidence at alpha equal 0.03 to suggest that the true population proportion of survivors is, now what did we say? Less than, so is less for CC plus MMR than for CC alone. So we don't have enough evidence to say it's less than. It could be there's some evidence, but there's not enough. There's not enough at the alpha is 3%. There is at the 5%, but not at the 3%. Maybe we should do some more tests. Regardless, I appreciate you watching. Hope to see you on the next one. Thank you.